Hello friends, so we have a question on application of derivatives. The velocity of a particular particle is given as Vt is given as e to the power sine t plus 4 sine t for t varying from 0 to 6. Now we have to find the value of t when the particle is at rest. So at rest means v will be equals to 0. So we are given the velocity as e to the power sine t plus 4 sine t, and equating this equals to 0, we can solve this for t and get the value of t for which the particle will be at rest. So solving this, we get the value of t as 3.35 seconds. So at 3.35 seconds, the particle will be at rest. Now in the B part, you have to find the acceleration of the particle when it changes direction. So you have to understand that when a particle changes direction, it must come to stop for a moment. That is, the velocity must become equals to 0 for that particular moment when it changes direction. For example, suppose you throw a ball upwards, so it changes direction at the top from which it starts falling again, and at the top the velocity of the ball momentarily will be 0 and then it will start increasing again. So v equals to 0 is the point where the particle changes its direction, and we have to find the acceleration for that particular point. So the acceleration will be identified at t equals to 3.35 seconds. This is the point where v is equals to 0 as identified in part A. Now to get the acceleration, we know acceleration is nothing but dv by dt, the first derivative of the velocity. The velocity has already been given, so we differentiate this, we get e to the power sine t into cos t plus 4 times cos t. So this is the expression for acceleration, and we have to find the value at t equals to 3.35 seconds. On putting t equals to 3.35 seconds, we get the value of acceleration as minus 4.71 meter per second square, which is the unit of the acceleration. In the E part, we have to find the total distance traveled by the particle. Now you have to understand that in between, as identified in part B, the particle had changed its direction. So if the particle had changed its direction, we cannot simply integrate the velocity with time to get the distance. Instead, we need to understand that as particle can change direction, what we will be getting ultimately from this is the displacement. So instead, we need to get distance. So what we would be doing is we would be integrating modulus of v dt for the whole time range, and from the previous part we know it is changing its direction, so we will basically be integrating it from 3.0 to 3.35 seconds e sine t plus 4 sine t dt. Then we know as velocity has changed direction, so we put another negative, and now it will be integrated from 3.35 to 6 seconds as given in the question, which will be e sine t plus 4 sine t dt. So solving these integrals, we will get 14.31 and this will be 6.44. So the total distance covered is 20.75, which will be approximately equals to 20.8 meters. So this is your final solution, and for more such questions and detailed explanations, do visit our website www.iitnacademy.com and register for detailed explanations and solutions.